standing here with Bob Fabry. He's a forage specialist. Bob, can you tell us a bit more about what you're going to do with the samples that we made from the grass?
Yes, sure. I've got the sample here, and we're going to give it to my colleagues here, and I'll show you what's happening. Let's go. Yep. The samples are coming in. They are scanned by the handheld of our sample taker, which contains all the information we need to fully analyze the sample. The bags are being opened here. On the little plate we spread out the sample so that it can be dried in a normal way. And at the end of this belt, the sample is being weighed, so we have to weigh pre-drying, and after drying we weigh it again. Then we have the sample without water and we can measure the dry matter. So here the samples are being weighed and put in the trolley. Once this trolley is filled, we can put them in the oven where they will be dried overnight. One of our ovens where all the silage samples are in. They stay here overnight. We do not dry them to 100 degrees. We don't do that because otherwise your sugars and your proteins will start evolving. They will have different shapes, so that will interfere with the results. That's why we don't dry them that high, but we dry them air dry, as we say. So now it's the next day, samples are dry, and we grind them here. We grind them so that we can analyze the whole sample into 1 millimeter. As you can see here, he's pushing the sample in the grinder, and it comes out in a little jar. That jar is a special jar, so that we can analyze it by near. This is our near-infrared sensor. This is where we do all the analysis. And as you can see, there is a little bit of space left at the bottom of the jar, which goes on the sensor, which is over here. And that sends out an infrared light. That light is being partly absorbed and partly sent back. And the way how much is being absorbed gives you a spectrum, as we can see here. And that is the fingerprint of the sample. And by measuring that spectrum, we can analyze all the important parameters on the report.
So what makes this way of analyzing unique?
This way of analyzing makes it possible to analyze really fast. There are some parameters, for example the digestible organic matter normally takes 1-2 weeks, and in this way we can do it really fast, as you just saw. Another thing which makes this unique in comparison to agricultural machines is that the database we've built up with all the samples all over the world, it contains thousands and thousands and thousands of samples, whereas the databases on those machines are really smaller, so they cannot analyze it as good as we can analyze it here. Because the machine isn't the hardest part, it's really the database behind it and keeping that up to date, and that's why we have a lot of quality controls here built in to make sure it always works and it always has the highest quality as Eurofins wants. So these are the ovens where we analyze the crude ash content. Grass contains organic material and inorganic material. Organic material we can analyze by NIRS, but inorganic material we can't. That is done in these ovens. We fill up a sample, put them in here, and we heat the temperature up into 550 degrees. And that way all organic material is burned. And what's left is the inorganic material, and that's crude ash, so sand and minerals and trace elements. At the moment, my colleague here is weighing out the sample. He did the same before the analysis, where he weighed in the sample. Now he's weighing out the sample. And all of the organic material has been burned away, and only the inorganic material has been left. If you look at the report, this is one of the fewer parameters we still do in the classical way, and that's because the infrared sensor does not work as good on inorganic material as on organic material, and because crude ash is really important in, for example, the feed evaluation like FEM or other energy parameters. We wanted to have the highest quality as possible. And that's why we still do this in the old-fashioned way.